Number one is translate. And if you guys will, flip around so you can see the back of the classroom. This way. If you look up there at our learning targets for first semester is on the left. Other than the two concepts that we have not quizzed on yet, that would be solve systems of equations or applications of linear equations. Those are the two that we have not done a concept quiz on. Can you see which one is the weakest of the skills? Translate, right? Do you see how fractions we almost hit 100% mastery? Some of the other ones are in there getting fairly close, right? But then when you look at translate, you're like, oh my gosh, we're out there at like, I think it was like 31% mastery. Not so strong. That is definitely our weakest area. And so we have this opportunity here to get better. Like every chance we have to work on this is a chance to get a little bit better. So let's take a look at number one. This is the translate. This is that skill you see up there. So this says product. Product means multiplication. So product of 5 and x would be 5 times x, or you could just write 5x, same thing. Is less than, pretty clear. It has the words is less than, twice the difference of x and 3. So I saw that the majority of us had that left side either correct or very close. The right side was a little bit more of a mixed bag. So twice the difference of x and 3 would be 2 parentheses x minus 3. So look at what you've got. Look at what I have. Any questions on one? Okay. Any questions at all? You guys know the parentheses have to be there, right? Right. And then the other thing is this, guys. I want to be super clear. If I have that in there too, what I just wrote up there, that makes this one not right all the way. Obviously, it's very close, but that would make it not correct. So there's that. Any follow-ups, any questions at all? Okay. Oh, yes, ma'am. Go ahead.
I had it the opposite way. Is that okay? Like
I saw that. Yeah, you basically said it backwards, but it was still correct. The relationship was still the same.
Just making sure.
Yeah, so I want to clarify, make sure you all understand what she's asking about. She had this, 2 parentheses x minus 3 is greater than 5x. It's the exact same relationship, just said backwards. So that's no problem at all. All right. Thanks for asking, Noel. Anybody else? Okay, then. So number 2. Number 2 says, find the slope of the following line. And that line is written in what we call standard form. It's there's a different set of rules to decide what the slope is based on standard form. The way that we have focused on is slope-intercept form. And so I want to put this into slope-intercept form to get there to the point where I can see what the slope is easily. So to do that, I need to solve for y. So I'm going to subtract 5x over. That'll give me negative 3y is equal to 10 minus 5x. And then I am going to divide everything through by negative 3. So when I divide by negative 3, I get y equals negative 10 thirds. And then remember that a negative divided by a negative is a positive. And so plus 5 thirds x would be your final slope-intercept form. Therefore, my slope is positive 5 thirds. Positive 5 thirds. So there are a couple of folks that as I walked around had some questions on that. Have my steps made it clear? Or maybe you have a follow-up question, how I dealt with the 5x, or why I need to do what I did, anything like that. Questions? Come on. Okay, so then the one that was left blank the most, or the one that was asked about the most, was 2b. 2b. So this says, write the equation of the line in slope-intercept form of a line that passes through negative 8, 3 and is perpendicular to 8x minus 2y equals 10. So guys, let me remind you of something. I need to have two things to find the equation of a line, and those two things would be a slope and a point that's on the line. That's right. So here is my little effort at organizing. My slope is this. My point on the line is that, whatever it is. Of those two items that I got to have to write the graph or the equation of a line, which one do I already have? I already have the point. What's the point? So I know for certain that the line I'm trying to figure out the equation of, passes through that point. I really, at this point, don't know much of anything else, but I do know that, right? I need to figure out the slope. And then, of course, the second phrase here that I'm going to highlight in red, that's the key to understanding what the slope is, right? So it uses this keyword, perpendicular. So do you guys remember the relationship between perpendicular lines? Now, what is reciprocal and opposite? The slope. The slopes are reciprocal and opposite. So here's going to be my strategy here. If I could figure out the slope of that 8x minus 2y equals 10, if I just did the opposite reciprocal of that slope, then that would be my slope. So I'll do this, I'll do this way off to the side. I'll say 8x minus 2y equals 10. How would I figure out the slope for something like that?
Subtract. Or put it in y-intercept.
Yeah, put it in slope-intercept form.
That's right.
So subtract 8x. That'll give me negative 2y equals 10 minus 8x. And then divide by negative 2. So that gives me y equals negative 5 plus 4x. Okay, so what's the slope of that line?
4.
It's 4. And so what's the slope of my line that I'm trying to work on?
Negative 1/4.
Right, we do the opposite and reciprocal of that. You're right, negative 1/4. Okay, so once I've gotten to that, most of you were on board with this. Noticed with the concept quiz on this, we're still not all the way there. Here's what I would want to do here. I'm going to use point slope to get started, and I'll finish with slope intercept. Can I do something really wrong here and point out I won't say a common error, but an error nonetheless? I've had folks, well-meaning folks, do this. Check this out. I've had people write this. Y equals negative 1/4 x. So far, so good, right? Plus 3. What is so wrong with that?
Because that's not the y-intercept.
How do I know that that is not the y-intercept?
Because, so the reason why we know it intercepts the y is this 0 because that's the...
So in other words, instead of negative 8 comma 3, I would need it to be 0 comma 3. Yeah, if that was 0 comma 3 for my point, then I would be correct, wouldn't I? But I am not correct because it's not 0 comma 3. That's not my y-intercept. Negative 8 comma 3 is just some point on the line. So I can't do that. What I can do is this. I can write, y minus 3 equals negative 1/4, parentheses, x minus negative 8. You can start off with point slope. And minus negative 8 is really plus positive 8. What is pretty much always involved in this process? Distributive. Yeah, pretty much always going to be involved here. Going to distribute across. Y minus 3 equals negative 1/4 x minus 2. You guys okay with 1/4 times 8 is 2? Like 1/4 of 8 is 2?
Yeah.
And then I just add that 3 over. And here's my final equation. Y equals negative 1/4 x plus 1. That's the equation of my line that goes through that point and is perpendicular to that other line. Okay. So this week our DMR quiz is on Wednesday because our test's on Thursday. So DMR quiz is on Wednesday. So we have one more day to review this. We'll do that tomorrow. So with that in mind, right now, do you have any questions on 2B? We're going to have one fewer day than typical this week. All right. So then finally, number 3. I didn't say this in the question. But did anybody identify the easier of the methods for 3? Substitution or elimination?
Substitution.
Why would you guys say substitution is easiest?
Because it already tells us what y is.
That already tells you what y is. In other words, one of the variables by itself, right? I agree. So what that means is because y equals that, in the other equation, wherever I see a y, I can remove it and replace it with what it's equal to. So I'm going to do that here. I'm going to say 2x plus something equals 49. At this point, I have removed y from my order at the restaurant, and I'm about to substitute something of equivalent value in. What's the only thing that's equivalent to y?
Negative 5x plus 7.
And so because they're equivalent, I can swap one for the other, or I can substitute one for the other. So that goes right here, negative 5x plus 7. And then from there, it's our hopefully now pretty familiar equation solving process of simplify first. So negative 3x plus 7, and then solve. So I would subtract 7 from both sides. This gives me negative 3x equals 42. Dividing by negative 3 on both sides. Did you guys come up with x equals negative 14? All right. So then, as you guys know, that is only half of our answer. We need the y to go with that x. How do we always find the other part of the ordered pair? Plug back in. You're right. Now I've got a choice. I could use that equation highlighted in red up there, or I could use this equation that I'm highlighting in blue. Which one's easier to do, red or blue?
Red.
Why? That's right. That's a key thing for us to notice. That pattern is super important. So then I would write y equals negative 5. I now know that x is negative 14 plus 7. So this would be 70 plus 7, right? Yeah, so 77. So my ordered pair solution for this system is negative 14, comma, 77.
That's a big.
Oh my goodness.
I would hate to run that.
We'd have to change our scale a little bit, right? Yeah. Definitely take a while. Okay, so guys, like I said a minute ago, you'll get it tomorrow again to practice this and ask questions and hopefully get really good at this. But then that's going to be your last chance before our DMR quiz on Wednesday. So do you guys have anything you want to talk about here? Nothing? All right. Fair enough. Hey, will you guys remind me that as you leave today or sometime before you leave, I want to hand back your old DMR quizzes from last week. They're graded in the grade book. I just wanted to get them back in your hands. So I'm not going to do that right this second, but before you go. Okay, I want to see if you guys can see a pattern here. And this is going to be very applicable to what we're going to do here today. But I also think that this pattern is very, what's the right word? Very, like common sense is the wrong word, but commonly used. So I'm going to start off super duper simple and see if we can work our ways to a little slightly more complex pattern. So let's say that I told you that a hamburger cost $5. And you decided to buy, you and your friends, 6 of them. How much is that going to cost you?
$30.
So $30 is right. So if the hamburgers were $5 each and you bought 6 of them, how did you actually come up with $30? What did you do in your head? 6 times 5, right? You took the price for each times the number that you bought, right? That makes sense? Let's do one more. Let's say that you were let's keep with the food theme here. Let's say that it's time with your friends, but it's morning now and you're going to go buy pancakes, and pancakes are $3 a plate. And this time you have 9 friends, including yourself. So 9 total plates of pancakes. They're $3 each. What mathematical operation would you use? And you would multiply what times what? 9 times 3, and you'd get? $27 of pancakes. That's a lot of pancakes, right? So you'll understand that the concept is if you take the price for each item times the number of items, you get the total cost, right? Okay, so let me ask you this. What if you were at a game and a hot dog cost $11? So sometimes if you get all the fixings and the sides and all that, it gets expensive, right? So you're going to buy hot dog, it's $11, but you're going to buy it not for 5 of your friends or 3 of your friends or 9 of your friends. You're going to buy it for X, an unknown number of your friends.
Crazy.
So it's $11 per hot dog, yikes, and you're going to buy X of these. What's the total cost going to be?
11x.
11, what operation? Times X, 11X. That make sense? Okay, so if you can keep that principle in mind, that'll be like a small piece of what we're going to do here today. That'll serve you really, really well. Okay, so if you guys would flip ahead, we're going to do one example together here, and I only have 3 of these that we're going to do. We're not going to rush at all. We're going to do this first one together, And then we're going to kind of scaffold the second one in a little bit, and I'll kind of help you. The goal being that by the time we're done today, maybe you have a decent shot of being able to handle number 3 by yourselves as much as possible. So, number 1, clearly, can you see this as a word problem?
Yeah.
I mean, we're approaching like paragraph size, aren't we? No longer is it like just one sentence or maybe 2, but I think we've got 3, 4 whole sentences here. So, guys, I am a fan of being very systematic about this. So I'm gonna try to teach you a way to approach these. I'm certainly not going to just say, hey guys, read it and figure it out. To some degree we're going to do that, but it's going to be in small systematic chunks. Okay? The first piece is really simple. Just read this thing like a story and try to understand what's happening. Okay? So I'll read it out loud for those of you that want to hear it. Read with me. It says, Team Sports Photography offers 2 packages for their school sports pictures. Can you identify with this, anyone? Doesn't this happen with every sports team?
Oh, yeah.
Okay. The first package includes a team photo and 8 individual wallets for $29. So in the olden days, they used to offer these wallet-sized photos. And a small little photo you stick in your wallet so that when you open your wallet, you can see your happy little child, cousin, nephew, niece, friend, whoever, right? Anyways, second package offers 2 team photos and 1 individual wallet for $35.50. Find the cost of a team photo and an individual wallet photo. So, first of all, reading this as a story, can you guys identify with this a little bit?
Yes.
If you've ever played on a sports team, have you not experienced this? It's when you realize this is about making money, right? It's like, hey, let's roll the soccer balls out there and play. And oh, by the way, we got some team pictures and they cost a lot, right? And so, anyways, pretty common thing. So from a story perspective, like purely, just from a, do I understand what this story is about? Do you get it?
Yes.
Don't even worry about the numbers yet. Just, do I understand? There's a sports team. There's pictures. We have the option to buy some pictures. That's it. Okay. So now we're going to pick this apart. And guys, here's what we got to understand. There's always going to be a relationship between the number of photos and the types of photos that you buy and the cost, right? Like if you want a big old, like fathead sized photo, you know what I'm talking about? It's going to cost you a whole lot more than a little wallet sized photo, right? I mean, I don't know who wants like a fathead sized picture of themselves on their wall.
Oh, yeah.
Maybe your parents would like that for their own wall, but maybe not you. I don't know. So, guys, here's what we're going to do. We're going to start to pick out the sentences. Now that we're going to try to figure this out, we're going to start picking out the sentences that have the information that we need. So, for instance, this very first sentence says, Team Sports Photography offers 2 packages for their school sports pictures. I honestly don't think that that's going to have much of anything to do with like the mathematic process we're going to go through here. So I'm just going to cross that sentence out. Make sense?
Yeah.
And it's not going to really play into it. I look at the rest of this here. I see some numbers in the second sentence. I see some numbers in the third sentence. So I'm not going to cross those out. And then I get to that final sentence. And I want to point out to you guys that that final fourth sentence, that's the sentence that actually tells me, here's the thing that I want you to find. So I'm going to mark this up, and I'm going to actually put a box around this. It says, find the cost of a team photo and find the cost of an individual wallet photo. This is going to be the first little bit of direction that we get. And I'm going to encourage you guys to look at this and decide what variables you want to use. These variables can have meaning, or they can be generic, like X and Y. Make sense? So what do you think? Would you guys like to use some variables that have some meaning, or do you just want to be generic with X and Y? X and Y is fine. So if we're going to be generic with X and Y, we need to define what X stands for and what Y stands for. And as I read those sentences up above, I see that team photo is mentioned first in both. So if it's okay with you, I'm going to say that X is going to stand for the number, it's going to stand for the cost of team photos, and Y is going to stand for the cost of wallet photos. So if you're going to be generic and use X and Y, which is fine because we're familiar with X's and Y's, right? We use those a lot. You don't have to do it this way. But if you do want to do this, let's define what the X stands for and what the Y stands for. So you should be writing this down. This should not be something that you just sort of like let float out in the air. You should be writing down what does the X stand for, what does the Y stand for. I noticed Josh he started working on this one a little bit. He used the letters T and W, right, for team and wallet. If you wanted to do that, that's fine too. If you're going to do this, make sure that it's clear what we're talking about. You guys doing okay so far? Okay, so then if you've noticed, we've crossed out the first sentence because that didn't really have anything to do with the cost of the photos or anything like that. We highlighted that last sentence because that's what told us what we're actually supposed to do. Do you see how the two middle sentences are the ones that have all the numbers and all the mathematic information that we need? So let's start exploring those. I am going to highlight this first one. It says the first package includes a team photo and 8 individual wallets for $29. So here's where we got to break this down, and here's where that little pattern recognition I wanted you guys to see earlier is going to come into play. For the first package, how many team photos are offered? A team photo, that's one, right? Okay, so one team photo. So if it's one team photo and each one costs X dollars, how much is that going to cost us for that part of the package? 1X, right? One team photo times X dollars, so it's going to be 1X. This is going to be the first part of my equation for that blue sentence. So I'll go with blue. Okay, so it's going to be 1X. But that, my friends, is not the only thing that you get in that package. What do you also get? 8 wallets. Okay, so 8 wallet photos. So if you get 8 of them and they cost Y dollars each, how much did that cost you? 8Y. So I'll put 8Y right here. Now we need to think of what operation happens between the 1X and the 8Ys. I've got basically my cost for my team photo, got my cost for the individual wallets. What do I do here? Yeah, I add them up, right? That gives me a total cost. And what is the total cost for this package? So I'm going to put 29 over here. What symbol should go between the 8Y and the 29? Equals. So let's stop right there. Do you see how we are trying to break this down piece by piece? Yes. If you just look at this thing as a whole and you just think to yourself, well, I'll just start writing some stuff down, and sooner or later you're going to hit one where you're like, whoa, I am lost. Yeah. And it's going to be a major struggle. So we're trying to break this down piece by piece. So notice that there is one sentence left that we have not done anything with, and this is going to give us our other relationship. It says the second package, so now it's a whole different package, offers not 1, but 2 team photos, but this time only 1 individual wallet for $35.50. So if you get 2 team photos this time for this one, and each team photo costs X dollars, how much is that going to cost us? Isn't it 2 times X? 2X? So 2X. This time I only get the 1 individual wallet. If I'm buying just the 1 individual wallet and they each cost Y dollars, how much are those going to cost me? 1Y. Okay. So 1Y goes here. What do I do to get a total cost? What do I do with those 2 expressions? Add them up. And the total cost was $35.50. So what symbol would go between those 2 expressions? Equal sign. So I want you to notice something. We have now exhausted all the information in our paragraph, right? We've written down all the stuff that's in there. We've translated it, right? We translated it from an English paragraph into a math equation, in this case, 2 of them. So now, remember, the goal is to find the cost of each of the photos. Well, wait a minute, what is that thing up there? When I've got 2 equations with an X and a Y, what do we call that? Well, no, those are the methods, elimination or substitution. It's a system of equations. Our methods would be either graphing or the 2 methods that were mentioned here, elimination or substitution. I have my opinion on this, but in this case it's purely an opinion. How many of you, by show of hands, feel like you would prefer substitution on this one? So, okay, does that mean if I say how many of you would prefer elimination? That's the vast majority of us? Okay. So I happen to be in the same camp as those of you that say elimination. I think this one could easily go either way. Purely a matter of preference on this one. Here are my thoughts. I do not see a pattern of opposites, but I do see a really easy way to get there. Does anybody have a suggestion on how I could get a pattern of opposites? Joe?
Times -1 on either one of the equations.
So, okay, if I multiply either one of them by -1, let's say this one here. Let's just picture this. Wouldn't that give me -1x? Right? Is that a pattern of opposites with the other x?
I like them.
I'll write it down.
It doesn't hurt them.
So just have to have the opposite symbol, or does it have to be the same number?
They need to be opposites. In other words, same number, different sign.
Okay, so times -2 on the top.
There we go. Yes, agreed. So instead of multiplying by -1, if I multiply by -2, that'll give me -2x minus 16y equals -58. When I add these up, you notice the x's get eliminated. I end up with -15y is equal to -2250. Dividing by -15 on both sides, I get y is equal to what?
Would it be 2350?
Nope. I don't think so. You guys getting 1.5? Oh, this should be -2250. Sorry. You guys get positive 1.5 here? Okay. So what does that mean for our question? What did the y stand for? Yeah, since we wrote that down, it's actually really easy to see. That means the individual wallets cost $1.50 each. We still don't know exactly how much the team photos are going to cost. What could I do with my 1.5 to help me understand? Yeah. Same thing we've done, and you suggest the orange equation. That is fine by me. So if I plug back in, I get 2x plus, I now know that the y is 1.5 equals 3550. You guys see the pretty familiar looking equation here? Subtract the 1.5 from both sides. We end up with 2x equals 34. That's a pretty pricey team photo. I got x equals 17. So the team photo is $17. So you can have memories of all your teammates and your coach for the low, low price of $17. Be impressed. What a deal. Okay. So let me propose something to you. Would you guys agree with me? And I don't know how you feel about this. Would you guys agree with me that doing the elimination or the substitution, if we were to kind of rank this, that's more or less the easy part? Isn't the hard part the translating?
Yeah.
So let's not just be like, oh yeah, just translate it, no big deal. Let's say, hey, let's translate it. It's a big deal. It's going to take most of your energy to do that. The whole elimination or substitution, I feel like you've gotten pretty good at that. Hopefully that'll go well. Translating, that's going to be the challenge. You guys have any follow-up questions on this one? Fantastic. Okay, so then let's see here what you guys can do with some of these other ones. I like this one. Let's do number 2. So this one, here's what I want you guys to do. Here's how we're going to work this. I want you to read it like a story. Then if you need to, set up some variables. And then I want you guys to try to write out the system. Don't worry about solving the system yet. What I want to do is give you a chance to do that. Then I'll check in with you and say, hey, here's what the system should be. Give you a chance to ask questions. Then I'll let you solve the system. And then, like I said, if we've got time here at the end, which I think we might, I'll have you try number 3. See if you can do that all by yourselves. We're certainly not going to rush this. So here's what you should be doing right now. Read it like a story. If needed, define some variables. And then translate, essentially. Translate what you see. This one was a little bit different. This one didn't involve any dollars, did it? It does give us some interesting things here, but basically the pet owner wants to make this rectangular dog run, gives us a little information. Then at the end, I don't know if you guys did this, but I'm going to go ahead and put this in a box again. It says find. That's a really key. Find is always a key word. It says find the length and width of the area that's enclosed for the pet. So again, I want to take your guys' suggestions here. Do you want to use X's and Y's again, or do you want to use variables that have some meaning?
Variables.
Okay, so how about the letter L for length and W for width?
Yeah.
Now, you are welcome to use X's and Y's. No one's saying that there's anything wrong with that. You just need to be clear about what your variables mean. And to me, L and W, it's an easy leap to think that L stands for length and W for width, right?
Yes.
Pretty straightforward. I'm wondering if anybody drew a picture of this. The other one, a picture didn't make a whole lot of sense. I think a picture makes sense here. So if I drew this rectangular dog run, maybe I would say that this is the length and that's the width. You guys okay with that? I just think maybe a visual would be helpful. I think you could easily do this without that, but maybe it's helpful. Okay, so let me give you the two equations here, and let's see how this went for you. It says that the pet owner wants to make a rectangular, hang on one second, a rectangular dog run from 28 feet of fencing. That tells me that that's kind of the limit on their fencing. They're going to use 28 feet of fence to do this. Are we not talking about a perimeter concept here? To build this dog run out of 28 feet of fence, like how could this person arrange it in a rectangular fashion? So here'd be my first equation for that red sentence. I'm going to say that 2 times the length, because aren't there 2 lengths? Yeah. And 2 times the width, because aren't there 2 widths? This is how I'm going to make this dog run. In order to use up all the fence, what would I have to do with the 2L and the 2W? Would I add, subtract, multiply, or divide? Add, right? Because we're adding up all the fencing that we're using. So if I take the 2 lengths and the 2 widths and I add them up, if I use all the fence, what should that equal?
28.
It should equal 28, right? Because you're using all the fence. This is a perimeter concept. This is different than the other one. 2 lengths plus 2 widths would equal all the fencing. Make sense? Listen, no one's saying that this is easy. In fact, I'm saying this is the hard part. So don't be like, oh, what's wrong with me? I made a mistake. It's hard. It's not the easiest part. Okay, and then the other one says if the length of the dog run is to be 10 feet longer than the width. Now, this is a little more of a straightforward translation. It says length, which is L, is, and is means what? Equals 10 feet longer than, what does 10 feet longer than sound like to you?
10 plus.
Or plus 10 maybe? Something plus 10? So the length is width plus 10. I think the green sentence is a little more straightforward. I think the red one is more complicated. So again, stop and look at what you have here. Now, if you nailed both of those equations on your own more or less, man, good for you. That is fantastic. It means you have a good handle on this already, and that's very exciting. That's great. If you messed up one or both of those, don't stress yet. Okay? Just try to learn and get a little bit better, and you'll get a lot of opportunities to practice these. And if you do continue to practice well, then I think you'll get better and better. Okay, so then, as I mentioned, this what's coming up here is probably the easier part. Did you guys notice we have a system again? 2 equations, 2 unknowns. Remember, the 3 methods you have to solve a system are graphing, elimination, or substitution. Nick, what do you think would be the easiest of those methods to use on this one?
Substitution.
Why?
Because on one equation, L is by itself.
Well said. Didn't he said it kind of quietly, but he said it really well. Did you guys notice the L is by itself on one of them? Set up really nicely for substitution. So here's one thing I could do. I can use this to substitute into the red equation. So I would say 2 There used to be an L there, but I've taken the L out, plus 2W plus U equals 28. So please notice the red equation, I've taken the L out. What can I put in place of the L? Not just numbers, W plus 10 specifically, because that is the only thing that I know of that L equals. W plus 10. Okay, so then what happens next? What operation would happen? What property? Distributive property, you're right. So 2W plus 20 plus 2W equals 28. Hopefully you're off and running. If you guys would, try to finish this one on your own. Come up with the length and the width of this dog's cage, this dog run. I'm just going to work quietly up here for the video, and you can always peek if you want. We'll just check your answer here in a second. Is that for real? That's so skinny. Poor dog. Barely room to turn around. That number was small enough where I like double checked. I'm like, did I mess something up? Because that doesn't seem right.
Do we have to do it like that, like in points or no?
So yeah, Noelle just asked, hey, do I need to put it as like something, comma, something? Because this is a contextual situation, like a length and width of a dog run, I kind of favor this instead. But if you are going to do that, always put it in alphabetical order, which you did. So that's fine. Okay, so I've got some answers up there based on my substitution work. I went sort of rapidly, skipped a couple of steps and all, but how you guys doing? Notice I put the units that go with those numbers in there. Okay. You guys settling into this okay? Yeah. All right, well then we got the one last one to go. So if you guys would flip over to, oh, I'm sorry, question.
What if you did it without any equations?
Great question. So the way the directions will typically work on these is it'll say, and by the way, there's number 3. Feel free to start on that if you want. I'm going to see if you guys do this by yourselves. It'll say show the algebra steps. And so what you did is you did like educated guessing and checking.
Mm-hmm.
So you should be prepared to get no credit for that. I want to see that you know how to execute a system. Because what if we go back to a cost situation and the cost is like $1.93?
Mm-hmm.
You're probably not going to have time to guess that,
Yeah.
right? So, yeah, remember, and you guys have done a good job with this all year, remember the point of algebra class is not simply can you get the right answer. The point of algebra class involves the right answer, no doubt. But it also involves can you communicate what you did, and did you use algebra? Did you use like a repeatable process that anybody could understand? Or was this Coy's super smart guess and check? That part's not going to be okay. So consider.
All right.
Okay, so number 3, similar to number 2, got about 5-6 minutes left in our class, and that might be enough time for you. It might not. I'm going to quietly work on this one, and we'll make sure we get answers for this at the end. But I want you to try this on your own, or with a friend if you want.
Mr. Anderson, what if you turn guesswork into algebraic step? Is that all right?
As long as the algebraic steps make sense. Yeah, if it's just like, hey, I started just adding some numbers up and came up with the answer, again, be prepared to get the guessing and checking score of no points. We try to make the numbers like nice so that we don't make the arithmetic the thing, but that of course opens up the back end of like, hey, somebody could guess and check this. As that's why we're going to be sticklers about, we want to see an equation. We want to see a system to make sure that you know what you're doing.
100% good. I'm simple, dude.
She just does that.
It's force of habit.
Well, I used to have this instead of someone. I did it or A's.
I don't know how to do this.
So X would be one piece, Y second. So then what you want to do, again, you want to break this down.
I don't know, I don't really know if I like them.
Because you always do in Spanish.
It does actually. How long is the whole pipe? Hey guys, we're up against our time, so let me show you the answer. It's right there. Check out my work. Check out my answer. Okay. So that means if you
I just had different equations. You know, I did A and B. You did the.
She didn't matter. We don't know.
I got it. Oh, I get it now. No, I mean, I have the foundation one and I have now for that. I just did it.
Okay, but that's why I got this one.
Where did you get it?
I mean, that's the name.
I haven't practiced it.
Is means.
Oh, I
Not
was
with it, you just need to put it more.
we should do it.
Plus one. Hey guys are good to go. Have a good rest of the day.
Yeah, it's like a series.
What? I lost my phone for 20 minutes last night.
Ben found it.
Ben found it in the grass.
Wow!
At where?
Do you actually think I would switch your phone though?
Yeah, I actually thought you took my phone.
Not even though I thought that you excited was excited for you.
Why are you so?
I got 4.
Callie.
Chase, will you grab mine?
Chase, do you have my phone?
Shut up.
It's not a lot.
Jaden, tell me how bad the memory test is.
I gotta go to Bible? I got an 88 on my